Spartak Jan, thanks for joining us. Please.
Yeah. Hello, everyone. Thank you for coming. I'm Spartak, working at Metric as a data scientist and machine learning researcher. And our team currently works at creating and improving Armenian LLMs and tools to improve Armenian LLMs. So the inspiration and also the problem is that there are not a lot of available Armenian LLMs, Armenian-speaking LLMs, and also LLMs that are kind of like Armenian, which like know Armenian writers, know Armenian history. And as you know, current data world is very English-centric, and the data available in Armenian is very limited. So our main problems with LLMs that are not speaking in English are, of course, the availability of good Armenian-speaking models. So, like, for example, Gemini talks pretty much good in Armenian, but it does way better in English. The second is cost. So a lot of these big language models, which are open source, are very expensive to host. And like ChatGPT and Claude, they will get expensive by the time as they accumulate in a number of tokens, and also the security, which is a very big topic. The cost actually itself also contains the tokenizer, which is also a very big topic. So a lot of us, the data in Armenian is not very much, is not a lot. These tokenizers do not process the data as efficiently as in English. So for example, like one simple sentence in Armenian can become like 40 or 50 tokens, while in English it's like 4 or 5. So it means like the cost compared to English is 10 or 15 times more expensive. And also, of course, the security is very important topic, as a lot of companies cannot afford to use such as premium language models as GPT, Cloud, or Gemini, as they do work a lot of with sensitive data of human sensitive data, and there are a lot of regulations about data that you cannot just, for example, export from one country to another, or data should only stay in one region. So that's a very big topic, and having local open source language model will solve most of these problems, especially the tokenizer, cost, and security. So as our foundation, we decided to start with embedding models, and in the last year we presented some of our insights when we were just beginning to work on embedding models, and actually shortly after that we just released and open sourced our embedding model, which is called Armenian Text Embedding 1. And at the time there were some pretty good embedding models like E5, GTE, BG, and others. But that quality was not enough for us. So we decided to pre-train the embedding models. We only chose the ones which were multilingual and not only specific in English, as the multilingual has better knowledge in other languages. And the key challenge here is that the data in Armenian was not enough and not in good quality. And from our initial training attempts, all of our models were worse than the original E5 model. So like you can see, by some hours metric scores, the multilingual E5 original was about 0.73, while our fine-tuned was 0.6. And after that, we decided to generate some synthetic data using big LLMs like Claude or GPT. And after the training, we decided to do weighted average of the base model and our fine-tuned model, which resulted actually in the best model we have so far found for Armenian. So this weighted average E5, which is also Armenian text embedding 1, is just the fine-tuned E5 version on synthetic data, and also weighted average of the base model. So we took more from our model. The coefficient was about 0.6 and 0.4 times the multilingual base E5. Yeah, and after that, we also, as probably everyone who starts to work on language models asks himself, how do you know if the model is good or not? And in Armenian, it's even worse because there is not any benchmark that you can measure the model. So we decided to contribute on the benchmark as well. We created Armenian LLM, which contains the university entrance exams for literature, history, and math. So these are mostly multiple choice questions in Armenian, which are scraped from original test samples from the university entrance exam website. And we also translated the famous MMLU Pro benchmark, which is one of the most popular benchmarks for language models. So after that, we started to work on the language model itself, and the first thing that we did, we chose Llama 3.2 1 billion. We just decided not to spend a lot of time finding the best model because none of them were any good. So we just stick with Llama. And the original tokenizer for Llama is very inefficient for Armenian. As you can see in the original tokenizer, this is some text that I forgot to put somewhere. But this is text for hello from digital world. So it's like a couple words, and of course it's in Armenian. But the original Llama tokenizer processes it into 41 tokens. So that was one of our biggest problems. And we decided to improve that. We had two options. One is to extend the existing vocabulary for Llama, and the second, which we chose, is to replace some existing tokens from its vocabulary and then do the training of the model and embeddings itself. So we chose the second option, and the reason mainly was just to not mess with the model efficiency and to not make the model even bigger. as if whenever you increase the vocabulary of the tokenizer, you also increase the LM head of the language model, and there is like it starts to cost more GPU, and it becomes a bit slower. So we just examined top 2,000 tokens from the Llama vocabulary that are not used in our existing corpus, and we just replaced with new Armenian tokens. And after that, with our tokenizer, the same sentence became like 10 tokens, which was pretty good. And the fertility score, which is the average number of tokens per word, the original Llama 3.2 had about 11 or 12 fertility, which means like each word in average becomes about 10 or 11 tokens. For the Gemma, it was a bit better, it was 4, but our transformed tokenizer was way better, about 2.1. So this was good enough for us. And of course, like whenever, even if you compare this to the original English fertility of the Llama, it is way lower. It's like 1.2. So we're nowhere near close that, but 2 is good for now. And after that, there is also a model initialization. As we chose the pre-trained Llama and we changed the tokenizer, there is also need for us to change the embeddings of that tokens, because before they meant something different and they now mean something in Armenian. And we decided to do it this smart way. Instead of randomly initializing each embedding, we try to preserve Armenian existing knowledge, which means that for every new token, we try to get the existing embeddings from the original model and then use that average of embeddings to initialize the new embeddings. So for example, if our new word token was dog in Armenian, and we feed it with original Llama tokenizer, it will, for example, make 2 words, 2 subwords. Then we just take the existing embeddings for subword A and subword B, and then average them and initialize the whole for the word dog as the average of these 2. Yeah, so after that we started to do our pre-training, and this is where we started to collect a lot of Armenian data. We actually collected about more than 80 different sources, including all of the data sets available in Hugging Face and GitHub and Kaggle, and then we scraped all of the publicly available company websites for social question answers or just about Armenian history and everything. We compiled most of the Armenian publications from universities, and we also did the voice-to-text and ACR from publicly available videos and audios. And that resulted about 70 billion tokens, which is not a lot if you compare it to Llama pre-training data. But I think that was the most we could do. And after that, we also did a lot of data cleaning. and ended up in about 50 million samples for Armenian and about 10% of it English. So our final
How many
data.
tokens is that? I'm really sorry. Can you say the number of tokens?
Final number of tokens was about 30 billion.
Great. Okay.
So we did actually 2 experiments there. One experiment was just to pre-train the llama with only Armenian data, and the second one was to include some English data. And we evaluated each step for Armenian and English performance. We did it by just taking, of course, there is the next token prediction and some metrics there, but we also took the intermediate layers of the language model, took the embeddings for them and calculated like average similarity between Armenian and English. So it was actually very interesting to see, as when we trained only on Armenian data only, we saw that the metric that is responsible for Armenian and English translation, which means like the words in Armenian are similar to English, that metric improved by the whole training, but the metric that was responsible for only English performance were hardly going down, like this blue line on the first graph. And the Armenian performance, of course, is going up. And after that, we examined that the model it just suffered from catastrophic forgetting, and its whole knowledge about English mostly were gone. So we decided to also include the English data from the most clean sources like FineWeb, Wikipedia, and there were a couple more. So the overall data proportion was about 80% Armenian and 20% English. And on the second training, we saw that both of the metrics were, at least English metric evaluation was not going down, and the Armenian was still going up. But compared to the Armenian-only training, it was going a lot slower, and it was actually a bit noticeable. But for us, the bilingual model was way better than the Armenian-only model. And then also the instruction tuning. Here we also did a lot of data collection and data processing. Some of them were reused from the previous pre-training phase, but most of that in pre-training were just text with no real instruction. So we started to get even more data, generated even more data for some specific tasks, like question answering, summarization, and overall knowledge, reasoning. And from our previous experience, we knew that we have to also include English instructions, which is are way more than available. So that was not a problem. So here again, we included about 600,000 samples for Armenian and about 300,000 for English, and we ended up with about 900 to 1 million samples. And actually we didn't even want it to have more, as instruction tuning with more data doesn't always turn into good. So like 500 to 1 million samples is probably the spot where you should be. And one tip for optimization that was significantly boosted our overall training duration was doing packing instead of padding. So padding is the standard traditional way of handling inputs, and recently Hugging Face implemented the packing method, which is instead of just padding, you concatenate all of your data into one big array, and then with positional indexes, the flash attention tool can very fast understand which samples are separate and which are correct. And overall, this just switching from padding to packing without changing anything was about 2 times or even more speed up in the training time. And it didn't affect the loss at all, like the loss were exactly the same. So that was it. Yeah, and these are mainly our key takeaways and learning so far. The custom tokenizer, we try to test also with just extending the tokenizer vocabulary, but it was way slower than the replaced tokenizer. The bilingual training, which might seem obvious, but for us we just didn't think that it would forget English so quickly. And optimization for things like packing instead of packing. And actually this is the wrong presentation format. But yeah, this was mainly it. If you have any questions.
Yeah, thank you. So you did tokenization change, you did pre-training, you did some SFT, right?
Yeah.
And then you get a model to talk in Armenian. And the scores that you showed, were these scores from ArmBench, or when you showed Armenian performance improvement, this one? Yeah.
No, this is the pre-training model's performance, and the ArmBench is mainly for instruction.
And how do you measure this?
So the Armenian performance is actually the English to Armenian similarity score, and English performance.
Similarity score, you mean you put both sentences?
Yeah, we took a parallel corpus of Armenian and English, and from the language model intermediate layers, we took like 5th, 10th or 15th layer embeddings, averaged them, and computed the similarity score for both of them.
I see. So it's not only Armenian evaluation, it's like cross-language evaluation in a way, right?
Yeah.
I see. I see, that's interesting. And then you had problems with SFT. That's the big question, right? So most of the compute goes to pre-training, right?
Yeah.
And this packing and other things that you mentioned, it's
we actually just discovered it only in the SFT phase, so
I see.
our
Okay.
whole pre-training was not very efficient. Yeah.
So you have these numbers on the benchmark or no? Like after SFT, you can already measure benchmark, right?
Yeah, actually on my updated slides I have some examples, but the SFT model that we got so far actually is not the best Armenian language model.
Uh-huh.
It clearly follows instructions. Like if you say something to do, it will do, but I think it lacks more reasoning, and overall it's not very, let's say, intelligent. For like multiple choice questions, it doesn't do like very well. But for translation, it does really good.
I see. And this is 1 billion?
Yeah.
Oh. Because, recently we were trying Gemma 4B for English, and with long context it gets very stupid. It's like,
Yeah.
so even in English. And yeah, if you're trying to do 1B, that's impressive. I see. Do we have questions?
First of all, thank you very much for the very interesting talk, and I admire your work. It's very useful for Armenian NLP. I have just a couple of questions. How did you measure like the fluency of the model in Armenian? Did you measure the perplexity of the model, and how well did it go? And I have also a couple of other questions about the tokenizations and the co-training. Usually, there is a very good transfer of knowledge between the languages that are linguistically similar. We even trained models, let's say, on Russian, Arabic, and Thai that were doing zero-shot Armenian at a decent level. Did you think about this kind of co-training of the models with linguistically similar languages? Because English is quite dissimilar to Armenian. When you talk about like the compound words, like otanavakayan is like 3 different words glued together. Something like German would probably have similar structure. So model might be able to have a better sort of transfer learning between those languages to Armenian.
So the first question was about how we measure the model performance.
The fluency, like how well it sort of speaks Armenian, right? You usually use perplexity to say, okay, what's the probability of the next word given the previous words, right? So you see that, is it actually speaking Armenian, or is it just speaking English transliteration of Armenian?
Yeah, we usually just go with perplexity as well. For the other languages, we actually try to do an experiment where we only do, so like we start the pre-training on Armenian, and then we do SFT only on English. And interestingly, after that, the model were also following instructions in Armenian. Not the same way as in English, but still, like, it learned we explain it as the main language for the language model is English. So like it tries, if it knows one thing to do in English, then it knows other languages, then it probably can do in other languages too. But yeah, that's actually a very interesting point. We haven't tried to train in any similar languages to Armenian, but we want to do it.
Sure, I think that probably the authors of the Quen tree will have different opinions about English being the major language. But yeah, hopefully there will be more diversity of the languages in the models.
Yeah.
Thanks.
Thank you very much for the talk. I'm learning Armenian language, and I'm interested in using LLM to help me with that. So my question is, what is the best LLM right now with Armenian support, and whether it's good enough for this task, or will it teach me something strange?
Probably, it's not this one. Probably Gemini Pro, I think. Yeah, I think you can learn it, yeah.
So is it good enough?
I think so, yeah.
Okay, thank you.
Thank you for the presentation and the work that you are doing for the Armenian NLP. So I have two questions. One of them is about the core data set. Have you thought about integrating the transliterated Armenian into the data set? And do you think this will help to the overall language understanding? Because I guess in the internet there is vast amount of transliterated Armenian language compared with the just Armenian. And then the second one, and the second question, which is very different. When you're using synthetic data, do you generate this data with your model for the soft instruction tuning, or you did use like Gemini or Llama for generating this synthetic data?
Thank you. So for transliterative data, we don't really have much. We have like a couple sources coming from Reddit or Facebook, but it's not really that much. We just haven't found. If you know, we can just talk maybe after. Yeah, for the synthetic data, we mainly just used Gemini and ChatGPT because our models were not actually that good. But one interesting thing that we think is an option. So for this instruction tuning model, it does follow simple tasks. So for example, if there is a sentence and the spaces in the sentence are removed, you can instruct it and it will fix the sentence or punctuate it. And there are a lot of, we have actually downloaded a lot of PDF documents, and whenever we try to parse them, the parsing is not going always well. There is also encoding issue. Sometimes the spaces are removed. Sometimes there are like 100 new lines inserted. So this kind of simple things, I think we can fix with this SFT model.
So, yes, thank you for the great job. I have one question. In order to avoid catastrophic forgetting, you used 20% English and 80% Armenian data. And my question is, why you choose 20% English data? Why not 10 or 30%?
There is no real answer to that. We just thought that 10 is less, 30 is more. Yeah, there were a couple of researches that suggesting to always include the original language of the model for at least 20%. So we just took that, and also we didn't really want it to increase the overall training time, as the pre-training was going for about 300 hours. So we just didn't really want it to increase that even more.
Okay, thank you.